Hello there. This is Group 35 with OsMowSis, CS6300, Fall 2019. Let's begin. The front end, as you can see, is a web React JavaScript app, and then the back end is Spring Boot. To run the back end, you go to the backend folder, run Maven Spring Boot run, wait for that to start up, and then on the front end, you do an npm start. As for the test cases, if you go into the backend folder and place any test cases you wish to run in the scenarios file, I'll go ahead and copy this. So then on the front end, go ahead and run CS6300, the file name. So what the React application is doing is it is sending the test scenario to the backend, and the backend is running the entire simulation and is sending it back to be kept in state in the front end, as you can see here. This is just a JSON response of the backend. It sends back a fixed two-dimensional array for every time step, along with some other information. The front end, if you intend to stop the simulation at any point, will also calculate the summary report at each time step. So you see here fences, grass, etc. All displayed as in this GUI interface. Not only that, but you can also see the mower actions at the bottom. Hitting next time step goes to the next object, and what each of the mowers does. Next, and there's also a fast forward button that runs through the entire simulation. Once the simulation is done, a summary report, the lawn size, the number of grasses cut, grasses left, takes place, and the number of turns. Let's try another scenario. It's important that the backend is restarted every time. A scenario is run. That is just a bug that we didn't get to fix. Looks like the application started. Submit the test case. Pulls up the simulation, and then once the mower encounters a gopher, the gopher disables the mower. You can see it by this black and white icon on the screen. At any point, you can stop the simulation, halt it, and it'll tell you the amount of turns taken and the summary report per the requirements. The design decision to have the entire simulation run on the back end and then come to the front end was due to how fast we noticed the simulation running, and the amount of information being passed from the back end to the front end was very minimal. So we decided to have everything in on the front end to be able to play with it there, go back and forth. So see again, submit test case, and go through one final run. The algorithm that we implemented was to avoid the gophers, and if it's low on energy, go to the start charging station, but it doesn't have to be the original mower's charging station. If it scans another charging station, it will remember that location and then do a calculation if it's low on energy to find the nearest one. One more thing to note is that the energy level of each lawnmower can be seen if you hover over the mower. Zoom back out, go through some steps, and check out the lawnmower energy level again. However, in our algorithm research, avoiding the gophers was very tricky, as they constantly go towards you. So if there's two of them, it is very difficult to cut the entire lawn. And that concludes our Assignment 7 OsMowSis project. Thank you.